what happens specifically in Google, Amazon, Facebook, Meta interviews. You go online, you do any of the books. It does not tell you exactly what is needed for L5, L6 interviews. Maybe for L5 you can get past, but not for L6. You need to put in little extra every single time.
Hey everyone, welcome back to another episode of Whiteboard Confidential. I'm Adam from interviewing.io, and in today's interview, our candidate takes on the event management layer of a large-scale calendar system. That means meeting creation, invitations, and notifications, all at the scale of 100 million users. Now, what makes this one stand out is how the candidate tackles scale calculations, database design, and the tough trade-offs between availability and consistency. The mock interview was led by an Amazon SDE3 engineer who has run over 200 interviews, and the feedback at the end is especially valuable, breaking down what separates a solid L5 from someone truly ready for L6. Let's get into it.
I'm a software engineer. I have about 12 years experience. Something like that. It's hard to say exactly how many years because I started when I was very young. But so I'm targeting like level 5, level 6. We'll see what type of leveling actually makes sense. And Amazon, Facebook's in the mix. Google's not hiring right now, but if I could, I would be applying and doing that over there. And yeah, that's about it.
So there is a big difference between hiring bar for L6 and L5. So I want to be very I want to understand for example at Amazon, are you going for L6 or L5?
SD2, so that would be an L5.
Okay, cool. Quick intro about myself. So I am presently a HD3 at Amazon. I have around 11 years of work experience, and I've been with Amazon for almost more than 6 years now. And and have taken close to like 200 interviews in Amazon. So yeah, that's about me.
That's all. Yeah. Are you a sometimes I have stats on it. Are you lenient? Are you hard? And like, what's your
I will not call myself as hard. I'm like pretty much what I have realized. I'm just at the bar basically. If I basically judge someone as like that, okay, not hire, the chances of that person actually hiring is 99% no. And I mean, whatever I have seen in my interviews is like probably the decision is basically the same. There was 1 or 2 instances where I've seen I did graded someone else something else, and the person was hired or not hired.
Okay, interesting. Yeah. So
I'm not lenient. I'm not lenient. I'm not super hard. I'm just okay.
Okay. Hey,
Cool.
It's an okay place to be.
Yeah. Cool. Let's get started. So this is a system design interview, correct?
Yep.
What we want to do is, I believe like everyone has used calendar systems, correct? You must be using it in your company. You must have used Google Calendar. So many different places we use calendar system. One of the things that we do on calendar is basically create meetings, correct?
Yeah.
So what we want to do is consider the calendar is given to you. You want to basically add functionality for event management, which is basically meeting creation, meeting like all the things related to meetings.
Okay. So the event, so calendar system, right? And so we're gonna go through functional, non-functional requirements here. So here we go. Functional requirements here. We're gonna say create event is probably one of them that I'm thinking of. Let's because you explicitly stated that creating an event. In this process, how are you thinking about the event creation process? Are we actually doing anything special? Is it just going on someone's calendar, or are we like making sure doing any validation of any type where that overlaps another like event and we can't schedule it, or what are your thoughts there?
No, we can schedule it. Nothing like that. I mean, like even in your calendar, like if someone is busy, let it be busy. Like you still want to like um you still want to send out an invitation, correct?
Okay, so let's say, yeah, you mentioned invitations as well. So when I create an event, um, do I'm assuming I can create an event for somebody else as well. So essentially, like I create an event for a user, and then user ID, and then also for there's gonna be like a
No.
time start.
So what do you mean by create an event for a different user? I mean, like, you can create a event and you can invite people for the invite people. Like, you cannot.
There we go. Yeah. Okay. So invite to event, and then this let's see. It's basically when I create an event, it gives me back an event ID. Mm, 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 here, and then when I want to invite to an event, then I provide it an event ID in order to add that person to that event.
Mhm.
So then it's user ID, and then there's going to be some APIs in order to register what events this person is registered to. So
Mhm.
get event, and then that's going to be like user ID. Um, there's also going to be like, how do we feel about authentication here? Because
Don't worry about the authentication. One of the requirement that I think is important over here is on the calendar system. If I want to see my all the events for today or all the events for a week, I should be able to see it,
okay,
or
yeah. So
even for a month.
yep. So start time and then end time are going to be inputs then, and then the result back is going to be like an array of event IDs, and then maybe the metadata that's associated to the event ID as well. So that would be like event IDs along with um, so event ID here. Let me make this an object, and then that object here, um, like start time and time. So yeah, this is good. I can see where
What
um,
about the notifications? I mean, like, someone should get a notification, correct? Like
y-
in prior to the meeting.
yep, we can have like a notification system as well. I'm thinking like you could have like a notification system that this notification essentially like has to get events, and then when the events are like
You can decide on
in
it
any
later.
way.
But I mean, like, you can decide on the design later. But like, we need to have a notification system.
Yep. Okay. So notification system. I'll add that as a note here. So notes, notification system. Let's go over like scale of this thing, because if we're creating a an event system, um, I like, and it's for everybody. So let's assume like half of the world's population is actively using this calendar system. So that's like 5 billion people.
Uh,
And then,
don't go such a high number. Let's assume like all together right now it's 100 million user, and 100 million user have already registered, and but it is a growing system.
okay, so 100 million users, and then let's say 10% of these people actually create events on a daily basis.
Mhm.
So that's going to be like 10 million users, and um, these 10 million users, maybe each item here is going to be its own like level of of scale. So like creating an event, I think is going to be significant. So we should do like a back of the envelope like conversion here or get events. I'm going to give you daily active users, so it's around 10 million daily active users, and then let's say people are creating like 10 events a day, let's say. I think that's reasonable considering like a lot of people use it on their daily function to create meetings and such like that. I think things are gonna grow with that. So yeah, let's say 10, so 100 million events a day. And so 100 million, so 10 million DAU, and then 100 million events. And let's calculate the queries per second on that. So queries per second would be like 100 million events divided by the amount of seconds. So 100 million. Let's do seconds in a day. Seconds in a day, it's about 100,000. So 100 million divided by 100K is it's about 1,000
Okay.
QPS. And that's pretty significant. I would say we're doing like throughput analysis here. So that's our throughput. We could also deal with the scale of the database as well. So if it's 100 million events, 100 million events, you have to store the user ID, time start, and time end. And then probably as well if it's been accepted or not. So Boolean there. It's pretty negligible, but I think I should call that out because if you invite to an event, then you're assuming that that person needs to accept or decline it. So I create user ID. Let's say like 8 bits for the user ID, 8 bits for time start and time end. So 8 times 8 times 8. You're looking at 64 times 8. So let me do that real quick. So it's 512, and then 512 times we had 100 million events throughout the day. So it's and then 100 million. Let's see, we have kilo mega. Kilo is 1,000. Mega is around 1 million. So you are looking at like a half a gigabyte a day. So 1/2 of a gigabyte a day. Let's multiply that to like 365. So it's pretty large. I'd say. You're looking at petabyte scale over like a few years of it in action. So it definitely warrants like sharding and things like that. So when we go into non-functional requirements, which I believe that we should venture into that, we have partitioning, which means we have to choose between consistency and availability, according to theorem and just experience. So questions for you. I mean, like, how do we feel about eventual consistency here? Because I'd imagine, like you said, these things, it's okay if the user like accepts an event after the fact, but it's okay to load up. It's more important that they know what events they have rather than having every single item on that event accepted and unaccepted and just like readily available for you. So yeah, how do we feel about looking at consistency availability over consistency?
Availability is, I think consistency is more important over here.
Is it? Okay, cool. So we were more concerned about what events.
But I want to I want to still give you right over here, and um, you tell me one thing, like uh, the important thing that I want to know is like consistency is important when you are saying availability. Like, are you so if you are dialing down or like maybe like not thinking about availability a lot, how much are you thinking about? Like, what's the sacrifice that you are trying to do?
Yeah. So the sacrifice that I'm trying to do here is I'm trying to get the output here. So this 1000 QPS below like a 200 millisecond load time for like a calendar.
Why do you need 200 ms?
Because that's around how long it takes to load up a web page. And
Where
I
do you
don't
need
really, sorry.
where do you need a web page of this one?
Good question. I'm thinking when a user wants to get their events and actually like looks at what events are happening for them is
Like most of the time people let's assume like not just web page, but people do it on like let's assume that you have a like a what do you call Outlook or something like that.
hmm okay. Okay. So we could we could do a few different things here. Yeah, if it's on Outlook, then
Even in web page you can do a lot of other things to make it faster.
yeah, you can cache things and things like that. I'm just thinking because then it would take longer for the cache to be refreshed. So we are sacrificing um, things like
But
uh,
but what I'm trying to understand is 200 milliseconds super important versus the availability.
yeah, it's the 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 availability is probably the 200 milliseconds, right? It needs to be readily available in order to grab that. The consistency is if that data is correct, and so that's kind of where my head is at. The I guess consistency is that like if an event changed for some reason, you'd want that change to show up pretty immediately on the front end, instead of the uh, the other way around. So there's the trade-off, right? Do you have to? Would you rather it take a little while for the page to load right when you want that change, or do you want it to not take a long time to load and then just have it readily available for the events that are there? Um, so
Okay.
yeah, I think um, so maybe let's go back and say that availability is more, or sorry, consistency is more important um, because of like we need to make sure that these events are actually correct and with the right updates. So um, yeah, what I'm
Just
thinking is like,
just want to give you this feedback that in actual interviews, these decision is led by the interviewee, not by the interviewer. So generally, like in actual interview, I will probably say you decide.
okay, interesting. Yeah, definitely a trade-off. Um, because you know, like if you're if you want to get your events as compared to get your events quickly as compared to like having a correct set of events, like there has to be a good balance point because
Mhm.
um, yeah, that you don't want to wait 2 days for your data, but you want it pretty soon. So maybe let's go through the high level design here, and then these things will kind of be flushed out as we go
Okay.
through it. We can still have some solutions for different systems because getting the events may be a completely different system or like approach than if we were to upload events.
Yeah.
And so I think it's overall just gonna come out. Um, so okay. We have over here and I'm not completely used to this system.
So there is a toggle whiteboard. So if you go to toggle whiteboard, you are already there. Okay.
Yep, got it. Yeah. So users are here, right? And then these users interact with our APIs. And let me actually grab all of our functional and non-functional requirements here. Oh, nice. Okay. So that we can reference them and just use them at different level. And interesting. Okay. So users are here. And then what ends up happening is we want to interact with a load balancer in order to get all of our user data. So I'm going to start with the get events here first. So the get events flow, because I think it'll become clear like what's actually happening.
Okay.
So over here, and then we have this load balancer here. This gives us the ability to scale pretty well. And then the users then get it from our data store. So a lot of different options for your data store. I would say like what's probably a better option is something that gives that high availability. So when it's updated, it's actually updated correctly. So or sorry, high consistency. So it's actually getting from the correct source. So what I'm thinking of here is probably, I want to say, a relational store, because we're gonna have all of the different events that need to be queried with different like time zones. So relational stores are really good at pre-indexing all of that data, so like MySQL and things like that. So load balancer, and then this hits our actual like our database. Actually, like it's going to be our server, because our server is going to want to do some extra stuff like authentication and whatnot, and like that just kind of, you need that layer between the two. There might be like some caching that we want to do here as well, or like some queuing. But yeah, maybe not so much with the get endpoint. Maybe if we want to do like a priority based system where we have a hotspot or something like that, then the server's more important. So the server over here, so here's our database layer. So it's a relational database store. And then the relational database, we can actually go over the schema rather quickly. So
Okay.
I'm going to do that. So we have
Why did you decide on relational database?
just because of the availability or the consistency aspect of it, because we wanted this to be a reliable system, and have the reliably get the data as it's being updated instead of a quick system. So if I was getting a consistent data set, then I'd have a key value store, because that key value is just O of 1, and then it's readily available and right there. Consistency is a little bit different, where you want to say, all right, hey, give me all of the data, give me the data that's for this time range, and giving me it most up to date, instead of it like being not up to date. So and also a relational database is good at storing time series data, because this is very much so time dependent. You have time start and time end. So if we're getting the events that are like starting at this time and ending before this time for these users, and then it brings back a set of data. So relational database, it separates it out, so you can actually separate like you're going to have like a table of user IDs, and then you have a table in order like true normalized fashion, user IDs, and then user events, and then you have like time start, time end for the user events. And you're going to pre-index that other table, not the user IDs, but the events table, so that when you query it with like time start A, time start B, it actually grabs it correctly. And there are other optimization techniques that you can do for that database that gets you even closer to um, the time series sets. There's new technologies that are coming out as well because there's some cool stuff. So yeah, let's do that. Let's do like user ID. This is one of the tables, user ID, and then like I'm gonna do the event ID over here, and I'm also what I'm gonna do here. I'm gonna label this users.
Do you want to do a separate, not here, probably like database design? I want to go deep dive into the database design.
Yeah, definitely. So like that's kind of what I'm doing over here. I'm creating the tables over here. So this entity over here is actually the like this is our database. So a relational database store. And I want to do here we are. So database. So user events, and then we have event ID, user ID. And then over here, I'm gonna recreate this over here, and then I'm gonna say like event ID, and then time start. And so this is important because if when we separate the two, then we can do like a really great indexing technique to like sort or index at some point. There's complex indexing algorithms that we can plug into, but I think sorting is just fine because once we find the start date that we're looking for, we basically iterate to the time end for these event IDs. So we join these two tables, and then we actually do the actual events. And this is great. This also prevents some duplication because we know we have user IDs that could be associated to many events. And so it's important that we normalize it.
Can you tell me one thing? When you say user event, so this is what exactly it is. This is the user ID and each event for that particular user ID.
Yes. Yeah. So this user ID and then the event ID for that user ID. There's also another table here that I should call out, which would be like just like users, the users table. So this would be like user ID and then like first name. So like their metadata attached to it.
Okay.
So like this is your user table. So all three of these would be joined if you wanted to get back that data. It is important. I think like this is going to be interesting here because most of the work here is going to be indexing this events table, making sure that these are sorted and when we replicate all of this data because it is high volume that we need this to do. So partitioning, we could probably partition by the time start and time end, or something of the sort. But we're gonna need to plug this into like some consistent hashing because that's also an issue that does come up. So like you could do it on some more consistent like and store a hash outside of this that hashes the time start and time end so that it's evenly distributed across all of these things. But I'm gonna say that's all that could be a whole nother diagram in of itself. And I think what we'll do here is I just want to call that out that could be an issue. So okay, so now this is our get events, right? Our get events flow. And then we can label some of these. We need to have another whole entire flow for actually storing these events. So when a user comes in over here, and actually that is what that label is going to be. Let's do another flow for not get events, but this is going to be create events. So create events. That's going to go through a load balancer as well. So pretty similar. Maybe even the same load balancer, but for like, just want to kind of call out that it's a different flow. And then here's the server itself that it goes through. And then this server here, it actually uploads to the events database, and the event ID, time start, and time end. And then also event uploads to the user events table. So yeah, I'm thinking about the hashing here and why it would be important. I think user ID, if it's like a UUID that's just like auto generated randomly, so it prevents collisions and things like that.
Mhm.
The I think we could partition pretty well by user ID. So
Sure, that was fine.
it gives us some consistent hashing. And like as I was thinking about it doesn't. If we do have a user ID for whatever reason that has millions of events, like let's say a promoter, then that could be an issue. But I think we're okay there. Because if a user has like 1,000 events hotspot, maybe we have like a map reduce algorithm or something of the sort. But yeah, so create events down here. So this grabs a bunch of different data. So maybe a little bit different. Like this is our so time start and time end, invite to event ID and user ID. So if I create an event, which is down here, I'm basically sending through the user ID and event ID. No, it passes back the event ID back to this system because we're creating it. So this user created this event ID and then this event. So this actually may need a different table that's like an invites table, which changes our design a little bit. So we just have a different table altogether because these user events here, this user ID created this event ID, and this user ID has this meta. Now we have another table that acts as kind of like a taxonomy table, where it says this user ID was invited to this event ID. So kind of like user
Can you can you not get it from somewhere? I mean, like from the data that you already have.
Yeah, I mean, good question. We could replicate it. So every single time we create an event, we say that these users here are invited to this event ID. So basically, it it saves it, and then maybe we have an extra field here, like is created or has been created. So you know who owns that event.
Okay,
Uh,
okay. Wait, Robert. Okay, tell me one thing. The owner information, like the creator of the event ID, in which table it should hide? Should it lie in user events or somewhere else?
it should be its own table, because that table, it would prevent duplication because not every single user ID actually created that event. So
Can you define that table or what that table will look like?
yeah, definitely. So like events, what would we call this? Like event creator table. Um, and then like it would be over here, and then it would be this user ID, and I think that's it. So over in the event ID. So very similar to the user events here, but
Why can't you put it in events table?
you can, but here, like you could add another field here. You could say like event ID and then
No,
like
not
create
not
it.
not 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 here. I'm talking about this one, events.
Oh, okay. You could also add it here, yeah, and then the denormalizing, or it would be also normalized. I was just thinking that it might be simpler to like divide out the tables if you're doing a different indexing algorithm. Um, just to like kind of show,
But
but
but but
you're right.
but you can. I mean, like, okay, tell me one thing. If you have multiple indexes on a table, is it a bad thing?
No, it's not. It's actually fine. It does separate it anyway. Yeah. So I think we're okay. Um, like created user ID, or like owner ID actually is what we would say. So owner ID, and then we should be good to go because that's normalized already. So if we wanted to query like for this who what user ID and for what event ID for that owner ID, then we could query that out, and then it would basically give us the events that are owned by that owner ID and the time start and time end.
Okay.
So yeah, and let's see. So we have our get events flow. We have a create event here. Um, so get events, actually the same flow over here. There's nothing different that we're actually doing. Um,
Okay, so
and
in the interest of time, it seems to me like most of the things will work. Tell me how a notification will work.
yeah, so notification would work as basically a cron job. So a whole entire service over here would just exist. So this would be like the notification service. And this notification service would like run a job every so often. And what we could do is as well as like replicate the actual processes here. So like it would distribute out like at scale because we have like 100,000 events, and we would say like daily notification job here would run, and this would be either its own service or it would be like fanned out to different servers. So you'd have like just a bunch of them, and then it would just run like either some SQL or some type of uh, like like logic in order to grab what we need from the database. And since this is partitioned in a way where all the user IDs are partitioning the whole entire system, we should be okay. Although I think partitioning it by time start would give us some more efficiencies, but I think it's okay because it would distribute it pretty evenly across the whole entire system. So this daily notification job here would just have a bunch of like updates there, and then this notification service most likely would be there are many different types of notifications that you could do, and so you'd have a different like system supporting each. Like if you're doing push notifications, for instance, usually that's an outside service that you'd have to make like a REST call to, or if it's an internal service, it could just be like a flag in the database that's set. So it really depends on what you have. I'm making the assumption that
So
most
yeah, let's do one thing. Let's zoom into notification service and let's assume that you are going to send an email.
oh, good. Yeah, that's great. So if it's an email job, then that's that email function. So it would, you know, we're actually writing the program now to actually do that, because I think it's important to outline what type of call is asynchronous and what type of call is synchronous in nature. So like the first step would be like get the data. So like query um for events 1 day
Mm-hmm.
day before event. So this takes time, and this would be a synchronous operation. And then the second one was like,
Let's say I want to send notification 15 minutes prior to the meeting.
okay, so let's say 15 minutes before event. So this job here would have to be like distributable. So it would be 15 jobs, 15 minutes before event. And then you'd say like, you know, mm, uh, like limit 15 for users before event, for users. And then this users here, you could actually distribute.
Wait,
Sure.
wait. Let me ask you this question. So, w- is it a cron job or is it like cron? Can you tell me first of all the frequency of the cron job?
Yes. Yeah. So the frequency of the cron job would be pretty much it wouldn't be every 15 minutes. You have to do it consistently. So like every minute or so. So and then I'm gonna relabel this. This is going to be um cron job every minute.
Okay.
And that
So let's say you run a cron job and you did a query for events that are in next 15 minutes, and let's say the query takes longer than 2 minutes, 3 minutes, then what?
yeah, then that's a problem. Because and the reason why I wanted to kind of break apart the logic here is because the users at the query really should be hyper optimized for that situation. So like in this range of IDs, right?
Hmm.
So you're only querying for like user ID between A and Z, and then this is distributed into like 1,000x or however many jobs that it actually takes to execute all of those queries for all of those user IDs. So it is optimized so that the query itself takes very little time. And since we're partitioned over here um,
Hmm.
on user ID, we should be good to go. And then,
So are you going to do so?
yep,
You are partitioning on user ID and your index is on.
yes. So I'm partitioning on user ID, and then there's an index on time start and time end, because we do want to make sure that everything these are ordered in a way that you can actually grab that data. So it's it's a little bit weird, but I do think it does make sense to partition by user ID and then do the indexing by time start and time end, because we're making some assumptions as well that a user ID has a finite amount of events, and we could do a back of the envelope conversion on that to say that someone has 365 times 10 uh, events a year, and we're never really querying outside of that range, so we should be okay. And then that is enough to fit in memory, so that we don't have to partition again based off of the user ID and the time start, time end of their events. Um, if that makes sense, like we should be able to index within the machine itself, and not have to worry about uh, like indexing overall.
Um,
Is that okay?
yeah, it's okay. Yeah, let's continue.
Okay. All right. Cool. So cron job every minute, query events every minute for 15 minutes before the events, and range ID, range of user ID, and then this is this is really important, like user ID. Um, like I don't know how I would like write this out, but basically I would say like, start ID and then end ID, and then this would fan it out. Then we push it to a queue. So this queue is important for like the next system to really do its work. Because like sending out an email, like that takes time, and like you want to basically this queuing service, you want to grab it pretty immediately. So I'm thinking like something like Kafka or like Kinesis or something of a sort in order to take those and push them out. So push the queue. Queues over here. Um, and then this would be like our email service that then would be on top of this queue. And this is important as well because this email service actually has like it fans out and fans down every single like time that it's needed. So if the queue grows past a certain level, then you're going to need more email servers. So you could replicate and start really doing more with that and start grabbing more from that queue. So it gives a little bit of buffer between the two. That this is where it gets interesting as well. Email service is quite complex because it's based off of your internet service provider. And once you start making those requests out to email, there's a lot of logic that goes into it, like bouncing, like what type of behavior is actually done there with bouncing. So you want to retry it a few times. If you're handling all of that logic and you're not actually sending it out to another email service like Google. So it depends on how much of that logic you want to handle. I could assume that it would get very expensive as well if you just offloaded all of that logic to a random service provider, like let's say, I don't know, like Salesforce Marketing Cloud, for instance, that could handle all of your email sends, but or like there's other competitors as well. So if you handle it in-house, you could save on costs at scale. But so it depends on what management and what we're looking to optimize here. But I could tell you that it gets complicated real quickly, and you don't want that to stop your jobs from executing, because as you said, like if this fails for a minute, then you just lost all the notifications for the people. So yeah, no, that's what I'm thinking here. What are your thoughts? Like,
So I'm
about trade-offs? Yeah.
I think like we are almost at time. Let me focus on the feedback and then we'll go from there. Sounds good?
Yes, please. Would love that.
I think you are there, okay. But still there are few things that should be improved. For a L5 engineer, I would have probably said like not very conclusive. Like I will be, I will say that positive to higher, but not slightly positive to higher. So we have something called like we have spectrum where basically we say not able to make a decision. Then we say slightly able to hire and strong hire. And then we on the other side we have a spectrum which is uh, not hiring, and so probably I would have said somewhere between not able to make a decision and I will say leaning towards hiring. Okay.
Go
The
ahead.
reason I will say is the concept, you did it well. I think while gathering functional requirements, you were okay. I think you can do a better job. Not functional requirement over there also you were okay. I mean, like actually non-functional requirement you did a better job than functional requirement. Um, then the second thing that I felt was missing was like specifically calling out these are the APIs you want to create. You kind of did it in functional requirement, but I mean, like you kind of mixed it. So that's basically like little bit of can be little bit of concern for someone that okay you think it in that direction, but I think it can be okay, it cannot be okay. So again, that's what I'm calling out. Like there are some few points that you can improve on. Okay.
Mhm.
Third thing is actually your database design was good. I was thinking like you might mess up on one or two things, but you handled it well. But you needed some guidance over here.
Mhm.
So I think whenever you get a guidance from your interviewer in your system design, it is actually considered a little negative.
Okay. Yeah.
Overall, you basically like for the CRUD operation, create events and all, you were on the correct track. From the notification service, you were again on the correct track, but you could have done better job. So basically, like cron job every minute makes sense. Every 15 minutes, for just for 15 minutes, next 15 minutes, not sure. Maybe you just grab it for next 30 minutes and put it in the queue. And email service generally basically have functionality where you can say, okay, send it at this time.
Oh, I
That
didn't realize that. Yeah.
that can be done. Other things that can could have been done, like when I told you email service, there are multiple steps in email while creating an email. Well, finding out the eligibility, then creating the content, then actually sending out the things. This could have been divided into three different sections. One queue, another server just for creation of a email template, another queue, then another server
Mhm.
just to get
Yep.
out the email. That will help in fault tolerance. Um, then third thing is about maintenance. Like we did not discuss anything about maintenance. Uh, how will you basically do operational load? What are the things that you need to worry about? What are the business metrics that probably you will worry about? What are the system metrics that you will worry about? So talk about all those.
Monitoring. Yep. Yep.
So so I will tell you what happens is like specifically in Google, Amazon, Facebook, Meta interviews versus compared to like what is actually available outside. I'm not sure if you are already in one of the FANGs, but what I've realized previously that like you go online, you do grokking the system design or any of the books, but it does not tell you exactly what is needed for like L5, L6 interviews for system design.
Hmm.
Maybe for L5 you can get past, but not for L6. That's a problem that I have seen.
Okay.
So you need to put in little extra every single time, like talk about operation load. So just to tell the fact that you are not just thinking about at this moment, you are thinking about long term.
Okay.
Okay. But again, I think if you do couple of more practice sessions, also one more thing, you need to be you were little over time. Generally, you get around 40 minutes for system design, and
Oh, okay.
we almost spend like 50 minutes.
Yeah. 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 Okay.
Okay,
Okay.
so you need to be aware about your time. But
Yeah. No, I appreciate
you
it. Yeah.
did a quick decent job. I think like. Yeah, as I told you, like this will be more of a leaning towards higher. So,
Mhm.
so let's.
Okay. So,
Mhm.
questions for you on the functional then. So I had some struggles with it. So, like, of course, I think you definitely caught on to that. I jumped into creating these different endpoints and these different method calls. Is
Mhm.
that okay to do? Like, should I have waited or like?
I think I will. Sorry, please go ahead. Sorry, I interrupted you.
No, please, yeah.
I think again, this is in very interviewer to interviewer. I will tell you very frankly on that. I would have not minded. in actual interview, because like eventually you caught up on all the requirements that I wanted to do. But there are chances that there might be a requirement for which you don't need an API, correct? And you could have handled by other things. So for example, I will call out in this, the function requirement should be that you should be able to do all the CRUD operations, correct?
Okay. Okay.
But
Yeah.
you did not share it anywhere.
Yeah, I didn't, because you have create, read, update, delete, right? And we have create, kind of have an update, but that's not like added event. Yeah, you're right. So, okay.
So, so for example, that kind of situation might happen even in your actual interview, where like you might have not caught that requirement, but you just basically said, okay, these are the APIs.
Yeah. Okay. So like your suggestion would be like next time I go into functional requirements, I do go through all of the CRUD.
No,
like
not just all of the code. What I'm saying is consider functional requirement as talking to your product manager. While talking to your product manager, you don't write the API. You basically just talk in English, write down what that particular person wants from you.
Yeah. Interesting. So like functional requirements, if I were to redo that or like do that in a better way, we would say, we have an event management system, and you want to create events, you want to get the events,
So
and you
in Amazon way, the way to think about function requirement is what does the user want?
yeah.
What will user get?
Yeah. So at me as a user, I would load up Outlook, and I would see all the events that I'm invited to, and I would have a button that would say click here to create event, and it would ask me the start time, start end, and who's invited to the event, and then I would click submit, and it would
Yeah.
notify those users.
So write your requirement in terms of customer, like what does the user will get, and based on that start writing lot of other things. That okay.
Okay.
Now like while discussing the APIs, at that moment you basically say, okay, for this requirement, this is the API I need. Oh, for this requirement, I don't need an API. This can be handled by this.
Okay. Yeah, interesting. Yeah, because I remember going through it, like you gave me the hint of ask about the notification system. So definitely I missed that, but it was good that you guided me and like told me about that. So I would say like that would have came out in that question. It's like where I create an event and then my users are notified, and then you as the product manager would be like, yes, I need some type of notification system so that my users know when they're invited to events, or if there's a reminder for an event, like 15 minutes before the event.
Yeah.
So
Yeah. So
okay.
So solidify the requirements early on and then design everything. I mean, like you got the points that okay, I will be leaning towards higher only because I will tell you, like the only reason that you got that leaning towards higher was your database design was correct. Like it is a tricky database design. A lot of people fail on that. And the other thing is your design was almost there. Like, but if so, that's why I'm saying it was leaning towards higher. And if it was a L6 interview, definitely not.
Mm-hmm. Okay. How could I have done better at the high level design?
I think like if you have written down the function requirements better and followed the correct steps, you would have done it better. That's it.
Okay. No.
So people don't realize it, but gathering the requirement and working from those requirements changes your design a lot.
Yeah. Yeah, definitely. Okay, cool. Yeah, this was very enlightening, and I super appreciate it. Like, it's good stuff. It's how far away do you think I am? Like weeks, months, years? Like,
In terms of L5 interview,
yeah, or and do you think I could get to L6 if
I
I
mean, like, you have
study?
12 years of experience. You have 12 years of experience. You can actually interview for L6. But I think for L5, you are like should not take more than like two more sessions. Like if you do two more sessions, like a mock interview, I think you should be there. So like just take like 15 days, 15 20 days. For L6, I do see a gap. For L6, I think it will can take like 3 months of time
Okay.
to
Yeah,
basically get there.
good feedback.
And um, if you want, you can read this design that I have written.
Okay.
So this is a design for this particular system, so you can have a look at.
Yeah, that'll be great.
And it tells you like how much time you should spend on each section, each time for requirement, how much time for estimation. So it tells you all those things.
Okay. This is
Yep.
great. Yeah. Fantastic. Availability and then consistency. Prefer availability over consistency. Yep. Yep. Kind of went through that. Good stuff.
All right, cool. Anything else before we go?
No. Yeah, this is great. Thank you so much again for your time and everything. So
Yeah, cool. All the best and enjoy your day.
All right, that's all we have for today. Thank you for watching. And if you want to get immediate feedback from the same people who make hiring decisions at companies like Google, Meta, and OpenAI, hit the link in our show notes to book your session now.